So, morning class. Um, today we're going to discuss about coding, or what's also called programming. But when we talk about coding or programming, we refer to the exact same thing. And we were going to define as well what we mean by coding or programming in few minutes. But since it's been a popular topic over recent years in education, it already was during the late 70s, I guess. Um, yeah. So during the late 70s, was also something very popular among scholars. I mean, programming or coding in schools. So we're seeing nowadays some kind of a new wave of scholar um, that promote the effectiveness, or at least the effect of programming on personal development, on skill development as well. So let's jump right away into today's game plan for this class. So yeah, like I said, I will first of all define some concept that we will use all the way to this class. Um, Also, we're going to have a little discussion about if coding is or not something that we can call literacy. We'll define as well what we mean by literacy in a few minutes, but um, many authors, I cannot name much of them, but many authors argue that programming has been. Hang on. Yeah. There you go. Here. There it is. Go. All right. So yeah, many authors argue that coding is might be um, the most useful. Well, I might not say the most useful literacy, but at least one of the most useful literacy skills that children and students have to develop, have to gain access to in order to um, fully participate in today's society. I guess we will get into in more details later on. Um, yeah. We're going also to discuss about codings in school. What was back in the late 70s, and what is about today. We're going also to address some approach that have been promoted um, around different countries in the world, European countries for most of them. So yeah, and the learning outcomes of coding. Of course, we're going to discuss about that. Difficulties and misconception about coding. This will be again really interesting to um, have a better idea of what are the main difficulties from both students and teachers when they're either learning or teaching coding. So Yeah, this is for today's class. But let's jump right into some definitions of some concepts. First of all, let me enlarge this. It's way too small. Okay, is it? Yeah, that should be good. All right. So, yeah, we must first define what we mean by coding. So, like I said, also called programming, which is the process of creating or manipulating a virtual program's code. The first images that come to your mind when we talk about coding is, the typical hacker with the hoodie and face mask and um, yeah. Good morning, you too, Alexandra. Thanks for being here. So yeah, this is the process of creating or manipulating a virtual program's code, and the typical stereotype image that we have is like, that hacker is black hoodie and typing real fast on a keyboard. Not quite, this is not quite accurate of an image. Um, yeah, and we were going to talk about that. Well, a code is used to run a program. So we know that code is, combination of textual element and digitals. So numbers, syntactic symbols, letters, words, um, most of the time called a variable and operators and so on. So yeah, this combination of digits and words actually creates. Yeah, I do not have a choice to spoil it right away, but this all creates some sort of language that is created by the use of by the use of the combination of digits and words. So this combination used actually to talk with it's kind of weird to say, but this allows programmers to communicate with the computer, which only responds by programs. So this is why we code. This is why people code in order to discuss with computers, but also discuss with other people through a computer. So yeah, and coding creates a program. These codes are used to run programs, and these programs are what are why you can actually use a computer. This is actually why you can see things. This is why you see. This is because of code that you can see this PowerPoint presentation. This of code you have access to your Facebook application on your smartphone. This is because of coding that we can discuss with people all around the world. Um, but we do not code when we use Facebook. We simply using the product of coding. So yeah, and a program is part of a machine's artificial intelligence. We can say that my computer, your smartphone, my laptop, all have their own intelligence, their own artificial intelligence that emerge from humans' intelligence. But this is way much faster than human brains. This is why we use algorithm and artificial intelligence in order to analyze a big set of data, um, which human brains cannot process at the same speed. But yeah, codes are used to run or create programs, and the addition, compilation of all the programs, the sum of all the programs actually create the artificial intelligence of PCs and other digital technologies. So, yeah. But coding is more than that, and we will see why in few slides. Why I say that coding is more than simply the process of creating or manipulating a virtual program's code. It's because there is, how can I say that? There is so many things with that we are interacting with on a daily basis that are made out of code that we cannot actually say that this is that coding is the simply is the process of creating or manipulating virtual programs code, but it is in some sort a kind of language, 21st century language, and this is why we're going to discuss about literacy. Okay, because yeah, I'm not going to spoil it. Programming was introduced during the mid 40s. Yeah, I think we talked about that when we first discussed of the emergence of computers and the emergence of digital technologies. All those digital tools, digital technological tools that we use, runs because of digits. That digit technology, those zeros and one, and everything this we use right now is made out of zeros and ones. But when programming, we're using words, we're using other command, variable, everything that's made out of words, and those actually going to tell something to the computer in order to, and the computer is going to translate those program into zeros and ones, so he can understand and he can actually send some electrical signals to the motherboard, to the yeah, the motherboard, so it can actually send electrical signals to all the other parts in order to run the programs that the user want the PC to run. So when programming was first introduced in during the mid 40s, is because when engineers tried to think of a way to program or at least store configuration the machines without having to physically switch the configuration. Because yeah, back then, if you want the machine to do something else, you have to manually unplug and plug wires, tubes and stuff like that, physically moving them and plugging them into other different inputs and outputs, so the machine would react differently, because you order, you physically move stuff. But engineers tried to think a way that those movements can be done, by simply pressing buttons, and they begin to store like multiple configuration of different set of unplug and plug, wired and tube. So so yeah, they store different kind of configuration. So when they press a button or when they choose a command for the machine to execute, then the machine will actually reconfigure itself in order to address that particular need from engineers. So basically, firstly, they were store virtual programs. Stored program concept in 1945 allows machine to store programs. So when machine can store program, because you have to keep in mind that machine back then. There was no visual display. There was no desktop. There was no anything that we can actually have, well, for our PC. So everything was, physically uh, programmable. So yeah. Yeah, so switching from an engineering, so physically moving wires to etc., to symbolic text, numbers, and symbol representation. So instead of unplug and plug everything, uh, these configuration was actually they were actually digitally and virtually represented. So it was way more easier for engineers to actually switch from one configuration to another. And programming continued to evolve a specific field through the use of computer, because, like I said, the first really programming kind of thing appears with engineers, but there's multiple nowadays. There's multiple field of study that use the program coding or programming. This does not only belong to the nerds and mathematic people. So physics scientists, chemical scientists, mathematicians. Um, Even in educational sciences, we use programming in order to analyze a big set of data, in order to produce results are out of our data. And this way, programming has continued to trend away from the materiality of the device and towards the abstraction of the process that control it. So instead of creating multiple configuration, they decided to split the idea of creating configuration by using codes, by using variable, by using specific configuration. And they decided to study that field. They decided to develop every words, every variable, every program that we can actually made. And the scientists back then that was performing different, that was exploring that new field, which was programming. Scientists that was exploring that field actually find that there was infinite possibilities for them to give information, to send information to a computer by only typing words and numbers and programming and stuff. So and it evolved quite fastly and with different branches, because language, like every language in the world, let's take for example French language. It has French language have different roots, different specificities. Even if you're, for example, in Quebec, they speak a different French language than in Paris, for example, or in Lyon, or in Marseille, for example. So and this has an historical background. Specifically thinking about French language, we can use as well the English language, or First Nation language as well. They all have specificities that come from maybe a common root. If we do take, for example, French language, it's come from Latin. Yeah, it has Latin roots, just like Italian language, just like a Spanish language. So it has the same roots, but if you speak French, it doesn't mean that you understand Italian, or it doesn't mean that you understand or you can speak Spanish. So it has different, it evolves differently, just like coding languages emerges from the same idea of communicating with a computer by using words and digits and numbers. um, but from the specific needs of programmers from different field, they were able to create a diversity of languages. I mean, diversity. There was at from today. There is actually, I don't think we can uh, we can put an exact number to this, but I think there's more than 400 different languages in the programming world. You know, there are 400 different programming languages that exist nowadays in only 60 or 70 years of development. So, for example, if you're working on websites, you're not using the same programming language as someone that is creating video games, for example, because is command, there is variable, there is concept that is not useful when you're programming a website. For example, adding clickable links is something that is interesting for someone that is creating a website, but this is something that is not useful at all if you're making video games. So yeah, you know, from the same programming concept emerged different, you know, multiple diversity of language. So yeah, its development led to in the 90s to Java's programming language and virtual machine that was not dependent from the physical computer. Yeah, because something that is very important to address is that when they first start programming, there was no extractable, you know, software from the computer. It came with the computer, the programming and stuff that wasn't cannot be separated from the computer. So every single computer has its own way to communicate with the PC, as his own, and there was no floppy disk back then, so there was no way to transfer a code from a computer from to another computer. So this was a very big problem, because programming from, for example, the Apple computer was much more different from programming on a Microsoft computer, and so language were not compatible, and there was, you know, nothing that links those two programs. But this is something that is you know, very concerning, and especially when you think about the fact that computer was evolving so quickly, so fast, that programs that were created through those computers were quickly obsolete. There was no uses for those programs, so you had to start over every time you had a new PC, which is, you know, kind of counterproductive, as I might say. So in the 90s, Java's programming language and virtual machine, so they decided to invent a platform on the internet. This was the way to have a common programming language and a common programming place virtual space to program. So I can program using the Java's language, and someone in France or in England can actually use the same programming, the same kind of programming language and virtual machine to code his own program in his home. And I could, take his program and run into my PC because it was compatible. It was fitting with the language and stuff. So yeah, it was a big progress in that way. So there was no dependent from the physical computer. There was no more program that was physically attached to the computer, physically to the physical computer. But instead it was on the web, so everyone can access it and everyone can share their codes, so it can be run on anyone's computer. So yeah, in order to make the most user-friendly programming environment, in order to make the most user-friendly programming language environment, for example, including words, not only numbers, structured program, organization, because there's a lot of like in every language, there is syntactics rules. There is something that you have to respect. For example, putting capital letter at the beginning of every sentence. I mean, this is something that is common to every language, just like the fact that you have to use variable for every program. This is something that is, universal. But if I take the Spanish language, when you put a question mark, you have to put it at the beginning, and at the end of a sentence, which is not something that you can see in French language. That you only put that question mark at the end of sentence. So this is a specific syntactic rule that exists in some language that doesn't exist in other languages. For example, the use of semicolon, that thing right there. The use of semicolon is something that is particular to some languages, but not relevant at all when for other programming language. So yeah, like I said, there's no way to verify this number, but today there is about 700 programming languages, and some are no longer used because they're not useful at all, or they're too old, or they were physically attached to the computer. So this is why there's some programming language that completely disappeared, just like languages. So why there's so many different languages in the programming world? It's a very good question. Because some might be old, like I said. There's some interest in using older language if you want to program some of the most basic command. I cannot give you example, but I hope you understand what I mean there. If you don't, that's not really important. But simply know that languages, programming languages, have their own use, have their own purpose. So this is why there's so many different languages. But not only for this reason, because some language might have more detailed functions, which gives the user more control over the program. I'm going to take the example of a video game programmer which is going to use a very rich and diverse language that allows him to do a lot of things. You know, from programming the movement, the keys, the sound, the visual arts, everything that is related to video games. So he needs a lot of code, a lot of coding, a lot of comments, a lot of comments, a lot of variables, a lot of functions. So yeah, he needs those information. On the other hand, if you're teaching programming or coding in school, you don't need those. You don't need to, you don't need to code the visual environment. You don't need to code the sound. You don't need. Some of the codes are pre-made, so there are little program that can be used as a code. For example, I'm trying to solve a problem, which is moving the bee to its flowers. So I have to type, move forward 3 times. This is only the thing that I have to. I don't have to code the environment where the bee is going to move. I don't need to program the sound that the bee is making when it moves. I don't have to program the color. I don't have to program the motion of the bee when it moves. Everything is done. It's already done. This is part of the interface, which make programming sometimes more accessible because of this kind of visual aspect of it. So and we're going to discuss about that later. So yeah, some language might have more detailed functions, which gives the user more control over the program, because some doesn't need to have that much control. There's also traditions and cultural background behind a language, like I said, and the comparison with human languages. I would call it that way. In the comparison with the human languages is really strong here, because there's also cultural background and traditions if I take as an example French language in Quebec. There's a lot of traditions, there's a lot of words, expressions that people, for example, in Abitibi-Témiscamingue are using, but here in Trois-Rivières we're not using those expressions, and sometimes it can cause some misunderstanding between people. So and just like that, there is also cultural background and tradition in programming. Like I take for example the video game environment uses coding language take its roots from specific language that actually might be different from HTML programmers, which is the language for websites and stuff like that. So yeah, tradition and cultural background. This is something that is important to note. And also, like I said, to answer specific function to program video games, apps, website, etc., they don't use the same language because they don't have the same needs. So yeah. Oh, this is a blank. Coding as there it is. Coding as the 21st century literacy. So this is the most the philosophical part, where we're going to think about what is literacy and why coding is something that every citizen should master actually. But at the same time, I'm saying that everyone should master the programming and coding, but I do not. Sorry, I do not fully master it myself. But yeah, literacy doesn't mean to be uh, perfectly mastering a language. It only means that you have the required knowledge and skills to use it as a functional, to make it, functional in your everyday life. So even if we defined coding as the process or of creating or manipulating a virtual program's code, like I said, it might be more than that. I said might because this is something that is still today debated. Is not unanimous amongst every authors and scientists. Since we're in constant interaction with digital technologies, coding is guiding most of our social interaction. Yeah. For example, if I'm sending messages, if I'm sending an email, I, without knowing it, use coding. I use the HTML codes. I use the other code that is used for mail. When I'm sending messages on Facebook, when I'm writing a post on Facebook, when I'm commenting on someone else's post on Facebook, everything is possible because of coding. Just like if I want to send, if I wanted to send before coding existed, if I want to send a message to someone else, I have to use the French language or the English language in order to communicate with someone else. This is the same thing with coding. This is the same process. I mean, if I want to communicate with someone else, for example, commenting on a Facebook post or replying a comment on a Facebook post, I have to firstly communicate with my computer and, for example, typing on my keyboard, sending information to my computer so it can print it. Print, which means a result of coding. But so the computer can send the electrical information to itself, print that information and send it to Facebook to so it can display the message that I have to address. So everything is made out of code. Everything is possible because of code. The advertising, targeted advertising data that is collected. Everything this is possible because of algorithm and artificial intelligence. So coding is guiding most of our social interactions, and this is the main the first gateway to say that coding is a literacy. We're going to go much deeper into that this idea. So we're communicating through and with those technologies, and consequently we're using coding without really knowing it. When I was preparing that PowerPoint presentation, I was actually using code. I was coding, but without knowing it. I was instead using the product of code instead of coding a program that will allow me to build that PowerPoint presentation. But still, this if I'm using a book, if I'm reading a book, I'm also using a product of literacy, which, writing and reading, that requires, reading and writing. So coding as a literacy also need, but to use the product of coding, you don't actually uh, need to know how to read and how to write codes. You simply have to know how to use the technology. Just like if I use a book in order to only watch images, so I don't have to know how to read French or English language. I simply have to read images. But by knowing the process and by knowing the code, and what makes, you know us able to use every technology, every digital technology that exists, every app, Facebook, websites, application, program, softwares, etc., etc. We do have to, we do need to know what's behind those programs, because it makes it makes it easier to understand what's the process behind. Everyone knows how books are made of. Everyone knows how words or sentences are made of, and this help us to understand the meanings of those sentences. So this is the exact same idea that we support behind the programming language, is that we need to know what's the process behind those codes, behind those programs, in order to really understand what they do, and how we manage to do it, and not only, you know, um, not only using it. So coding as a way to make information accessible, digitalization of knowledge made possible because is, made possible because of programmers, or people who can code. Um, just like knowledge was accessible to those who know how to read and write back in, in Renaissance. So yeah, digitalization of knowledge, just like, print press allow books to be the multiplication of books and knowledge as the same way. So digitalization of knowledge is made possible because of programmers, or people who can code. And the only way that I can have a full access to the information I'm putting on the internet is to actually create my own platform, create my own, using a language in order to create that platform, to share those ideas. Because using, for example, Facebook, I'm not 100% protected to some sort of algorithm that will, deactivate my comments, or delete a post that I made for different reasons. So digitalization of knowledge is made possible because of programmers, and not only common knowledge, like Scholar database, search engines, etc., but also like compromising knowledge, I would say. I'm not quite sure if you watch the documentary on Edward Snowden, or on Julian Assange, or simply the Great Hack on Netflix, the movie The Great Hack. But because some people, some hacktivists, like we call hacktivist. Some because of those people knew how to code, they were able to create a free platforms of free speech to denounce everything that they saw. For example, Julian Assange, when he creates the WikiLeaks websites, um, he actually code everything from the beginning, and he could simply have posted it on Wikipedia or on other website that was owned by a company or someone else, and that other website could have easily take out that information he leaked, um, but because he know how to program, how to code, he was able to share some shocking information um, to the rest of the world. So this is an example of knowing programming languages can make can give access to every to a much larger scale of knowledge. Coding as a way extend so as a way to extend social activities to the whole world, or at least a big part of the world. So code enable people to gather around a common cause. For example, social medias. It makes some democratic actions more accessible or more frequent. For example, debating. We no longer have to be physically inside a physical space to debate with other people. We actually only have to gather around a Facebook post, so we can engage discussion and arguing with other people. It makes some democratic actions like political advertising are now mostly on the internet. So coding made this possible. So it changed actually how people their democratic actions. It also changed the way political parties, just like I said, political parties, the way they promote their messages. Just like TV has changed the way they promote their messages in the early 60s. So coding made big difference. It Coding makes a big difference in the democratic society. It changed the social interactions between people. It's changed the way that we discuss. It's changed, the way that we simply communicate with people. And the coming of coding as, in part changed the way people communicate with each other, like I said. And, this being said, many authors compare coding with reading because of its social and historic impact on today's society. They also often call it 21st century literacy. And as John George Kemeny wrote, popular mathematician, American mathematician, he wrote in the 60s that computer literacy will be a condition for employment because the computer illiterate will be cut off from most sources of information, which is, not that false, as we can take a look at that quote 60 years later. If you don't know how to go on the internet, if you don't know how to access to a mailbox, this is something that is going to be very, very difficult for you to fully participate in society, because things are moving from handwriting to digital writing, as I should say. And if you do not master those software, well, first of all, those software, you will simply not be able to communicate with and fully participate to society. The other thing is, if you do not know how to, the main principles, the basis of coding, you won't even know how those softwares are working, and some of those principle are, can be transferred to our to the way that we use those softwares. Knowing how they works makes us, makes it easier to understand how to use it. So even when computers were not as present in our lives as it is in today's society, it was saying that, and I cannot say that it was 100% false. So when Kemeny calls people who don't know how to code illiterate, he implicitly meant that coding is a language. I love to call it the robots language, because digital technologies are in fact robots. So this is a way that we can communicate with our computers, and by the same fact, communicate with other people. Sorry. This is not a meaningless claim to say that coding is a language, because language is not only about using words into a sentences to communicate. A language, it has a multiple aspect. It has a cultural aspect. Language has syntax aspect. It has its own rules. It has its own, pronunciation. It has its own pace, as I can say. And a bigger claim to argue it's a form of literacy. It's because literacy refers not only to the ability to read, write, or understand a language. It means that coding has a functional role required to understand society and its composition. Last class, I was talking about algorithm and big data. This is exactly what I refer to. If you do not know what algorithms are made out of, why they react that way, why they're used that way, I mean, you don't have to be an expert in coding to understand some main aspect of programming language. So, and because it has become a function, it has a functional role in our society. I mean, every transaction you made with your credit card, every interaction you're making with other people on Facebook, every mail you're sending, um, every survey you answer on the internet, every everything now is made out of code and programs. So not understanding some basics of coding, some basic principle of coding, um, actually makes you, not fully functional in today's society where code is everywhere, is ruling uh, many of the aspects of our society. So, first of all, literacy can be defined as a human facility with symbolic and infrastructural technology, such as textual writing system, that can be used for creative, communicative, and rhetorical purposes. Computers are the tools made possible by coding, just like books were made possible by writing. But for a tool to become literacy, for language to become, literacy, it must first be central or infrastructural to society's communicative practice, just like computers are in today's society. So I think this is this is something that everyone can agree with. Is that everything that we uh, everything that we use, not everything, but most of the thing that we use on a daily basis, it's really important, on a daily basis, is made actually out of codes. So it has become central to today's society, and most of the jobs that were not usually, using codes in their work, nowadays they are using it. They need to understand that language to perform their everyday job. For example, journalists. So they have to do the placing the programming the text font and character size. They have to insert images in their article. They have to, everything that was usually made physically possible is now made out of code. So journalists have to program their own article. So they have to learn and understand some coding basis in order to fully fulfill their jobs, their duty. So yeah, and considering something as literacy or not depends, well, first on the social context. So the ability of writing and reading books became central to societies when books took a central or infrastructural place in people's lives. Sorry, so it became a literacy. For example, in England on the 11th and 13th to the 13th centuries, or in the United States of America, when they they started to think of a way that they can configure, or they can think of their own society where so they had to promote those ideas. They had to promote those those freedom ideas to an entire country. So they had to teach people how to read, because it has become central to their society. And I don't think that today we can argue that reading and writing is not something that is important. On the opposite, is it it is a functional skill to know how to read and to write in today's society, just like coding is becoming something that is necessary. It is now appropriate to call for a computational literacy. I'm not going to into too much deep into that computational definition, but which is defined as the ability of reading and writing computers' language, because of the omnipresence of codes. There are everywhere from the 1980s, when computers were cheap enough for most of the people. So from that point, I think, regarding to everything that I've read on that topic, I think it's from 1990, when computer language became a functional skill. In his text, V defines computational literacy as the constellation of abilities to break a complex process down into small procedures and then express or write those procedures using the technology of code that may be read by a non-human entity such as computer. So everything that makes a computer works, or a cell phone work, every language, every pieces of a program is understanding how they interact with each other, how what they're made of, is actually considered as a computational literacy. It is something that makes people functional. So to claim coding as to claim that coding has become functional literacy, has become a functional literacy, its impact has to go beyond the ones who are usually coding. Yeah, like I gave an example of journalists, and the task that once belonged to programmers have now been integrated to daily routine of other people's job. And I wouldn't be surprised that that coding will be something that teachers will be using on a daily basis, because teachers have to produce sometime have to produce their own material, their own teaching material, and we will probably see something similar to journalists, where they have to put their article on the internet. So yeah, journalists now have to know how to program their articles, use specific protocol to ensure the anonymous of their work and their informant. For example, communicating with whistleblower. An example, to make sure that no one spies on them, that the government not spying on what journalists are doing, or what mail they are sending, or whatever. They have to understand how the internet works, how to secure their own practice. So yeah, this was the example I gave. It also has to impact for coding to be defined as a literacy. It also has to impact democratic practices. As Boninardi, a professor from the University of California, wrote, the technology's consumers, in that case citizens, has to know the basics of programming, so that the many decisions of democratic society face about the use of computers, including difficult issues of privacy, freedom of speech, and civil liberties, can be approached by ordinary citizen, or citizen that don't make programming a job, from a more knowledgeable standpoint. Um, we talked about personal data and cybersecurity last class, and it was something that is very concerning. But um, what if decision makers and what if government and politicians don't know how those algorithms? What if they do not know how coding works? How can they, you know, um, well, first of all, recognize that there is a problem, and second of all, think of a way to address that kind of problem. Think of how to write laws and act that actually will protect citizens. If they do not know how code is working, if they do not know how algorithm is made of, how can they recognize that problem, and how can they address that problem? This is something that is very concerning, because we're not going to see, well, this is my own on editorial note, this is my own thought on this topics, is if they do not know how it works, how can they protect citizens from that kind of practice? Um, on the other hand, if citizens don't know how coding is working, they don't know how an algorithm can influence people to vote from a party to another party, a political party to another, or another political party. If they do not know what codes that code influence, first of all, and how it can influence a voter to switch his vote, how they're going to think that actually there is some democratic issues in society. If you watched The Great Hack on Netflix, you know you clearly understand that idea of if you don't know how the codes are interacting, or I don't know who said that, but uh, the author said, program or be programmed. This is something that is some sort of or some sort of thing that George Orwell might probably have said, or Aldous Huxley probably have said. But yeah, if you want to make it simple, program or be programmed. And if you don't know, if you're not able to recognize that there is a problem, or there is something that is not ethical, or that is not moral in the way algorithms are, for example, taking information on you, if you're not able to recognize that, how can you first be concerned about that issue, and be aware of that issue, so you can uh, raise your voice and say, sorry, but this is this practice is not right. We should address it. We should write an act that protect us on that standpoint. Because leaving decisions that concern software design and usage to the small group of people that have achieved a satisfactory level of computational literacy disempowers those who only consume rather than produce software. This is the best way to say it, actually. Program or be programmed. For example, if programmers that work on the Facebook website, if there's only a handful of a hand of people, a small group of people that can read and that know actually why some practices are wrong, how can, have the power to change things, just like reading has the same effect. People who do not know how to read and write in today's society are clearly disempowered over those who know how to read. You know, um, people that do not have access to education as well are disempowered over people that have fully access to an educational system. I'm not saying that, yeah. So, and there's historical evidence that support the statement. Going, only going to quote Luther in the Christian Revolution, um, where he actually translate uh, the Bible from Latin to English and distribute it to people so they can really understand what, the big difference between what the institution was telling uh, um, uh, people to do versus what the Bible actually told people to do. So there's, multiple evidence of that in order to support that kind of statement. It's educational institutions' job. It is institutional. Sorry. It is educational institutions' job to literate, as I can say, the future citizens. So, to literate citizens to computational language does not only concern the learning of coding rules and conventions, as learning English does not only implies grammatical and syntax concern. Yeah, this is something that everyone can relate to. It's a social process rather than a technical process. You don't write over and over a word multiple times in order to understand what it means. You have to put it in a context. You have to look out for a definition. You have to understand what is the root of that word, so you can transfer that knowledge into other words that you might want to know what they means. So this is more than simply, typing codes and knowing all the variable by heart and doing everything, uh, technically doing everything on a technical standpoint, or simply typing words and stuff on a program, virtual machine. It's a social process. And because programmers communicate with between each other with their programs, there have to be a common understanding of the programming language between them. So there is always movement, evolution of that language. So yeah, it's a social process, just like language. Literacy implies social aspects that are inherent from its language. Communicating in English, French, Spanish, etc., 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 as a social practice with specific traditions, values, contexts, identities, aesthetics, etc., etc. Most, of Quebec's French expressions come from direct translation from an English perspective, or the mutation of French word and English word, to produce some new words, some new expression that define, traditions and identities. Also, language is it's language carry values and cultural aspect more than people can think. Um, Losing a language is like losing our identity. Um, for example, right now when I'm speaking in English, I'm a French speaker, and English is not my first language, so there is some expression that I use, there is some word that I use that, or the way that I'm saying, or I am pronouncing words that actually comes from my French background of language. And this is something that is really important, is that when we're learning programming, when we're learning coding language, we have to actually think of the word differently, because of words or variables that we use inside a program are, English words, does not have the same function as the use of that same word in the English language. So coding shares that same idea because computers are social technologies in their design and their deployment. Coding shares that same idea because computers are social technologies in their design and deployment. Structure of coding is socially established by the ones who participate to its construction to serve a common mean, the intelligibility of that language, that understanding of that language. So it has, it is socially constructed. Like I said, there is exchange between programmers in order to, for example, someone's programming a Facebook website, and someone that is coding a Twitter website, they will use the same language, but they won't use the same aesthetic. They won't use the same conventions when they're writing their program. And if they want to understand each other from a programming perspective, they have to share a common values, and they have to socially exchange their thoughts, their idea of the program. Just like calling certain verbs as active verbs, which is something that is not specific to French language, though. We have verb groups, as we can call, which is different from the active verb, or defining the uses of the s, that apostrophe s as a possessive function are socially shaped language values. Because this is something that we don't have in French. This is something that Spanish language don't have, like I said. So it is just like coding, language coding is a social construct. And developing a computational literacy offers more than an access to the most used 21st century communication language. It enables us to be more critically engaged with the software we use on a daily basis. It also gives more people the capacity to express themselves by allowing them to create their own platform and application, using their own website in order to communicate, where communication is not regulated or controlled by others' vision of freedom of speech. I gave the example of WikiLeaks. This is the most relevant example that I have in mind. From a school perspective, teaching computational literacy allows the development of many other skills that are not exclusive to programming. For example, problem solving, because coding is actually writing a way to go from A point to B point, from start to finish, what the outcome I want to achieve, thinking of what the outcome I want to a program to have, so I can think of a way that I can go from that starting point and achieve that outcome. And that problem solving kind of a thing, the way that we think of how to solve problems, this is not something that is exclusive to the to programming. This is something that we that that we have to use every day. We have to solve problem every day. So yeah, this is the kind of skill that is not exclusive to program language. So yeah, coding as something that is critical, I should say, in today's society, and critical to and it is critical for a future citizen to fully understand what coding is all about. I talked about that the first developed language, the first developed coding language with the learning perspective in the 1960s was the Logo language. And the Logo language, appeared in schools during the 1980s to serve a more technical need created by the Cold War context, where war was no more on the battlefield, but was on internet and stuff like that. So there was to serve a more technical need, but then left behind within a decade at the expense of other skill that was considered as more useful at that moment. For example, natural sciences was promoted at that moment in time, because education is not, how could I say that, curriculums are not the reflect of what's most important to learn. Curriculum are actually a reflection of society idea of what's best to learn for their citizen, for their future citizens. So the fact that after the 90s, coding was take out of programs and schools doesn't mean that it was no longer important. Simply because society decided that there was more relevant, I should say, matters. There were more relevant subject. So and in today's curriculum, we see that coding is coming back. The importance of coding is now more than ever evident. This is more than ever an evidence. So and now learning how to code and learning with the code has been introduced in many curriculum around the world. For example, England, Greece, Australia, etc., etc. Partly because of its accessibility, because in today's school, in elementary school and K-12 schools, they do not code just like programmers do. They do not have a blank, dark virtual machine where you type in commands without having instant feedback of that program. Because today the accessibility of coding is made possible because of the graphic environment, because of robots that we can use to give an instant feedback. For I'm going to give the example of Bbot or Ozobot or Neo the robot, or that are physical robots that produce what the code actually tell them to produce. Those code are actually created by the students. And coding is, for example, with Bbot, that little bee that it's actually a robot. Bbot, yeah. So coding a Bbot is not made, not always made with the use of computer. You have button on that robot where you can press and actually program certain sequence, set up some the movement of that robot. So it gives a more a better accessibility to the coding language, even though this is not learning the syntax, learning everything that makes literacy, coding a literacy, but this is a beginning. And you have, on the other hand, programming softwares that is used again in K-12 or elementary school students, that give them more precise or more specialized command in order to understand other principle of coding. For example, looping. Instead of repeating 10 times a command, or writing 10 times the same command, looping, saying that take that part of the program, that part of the code, and repeat it 10 times. Or programming condition. So if there is the X value somewhere, then use blah 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 blah. Else if blah 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 blah. So there is some function that is slowly integrated into the learning of code, that and this is made possible partly because of the accessibility of that language. Because coding is not something that it can be scary, of course, but it is really not. And now learning how to code and learning with the code has been introduced in many curriculum around the world for three main reasons. First of all, for the obviously economic reason, because you might probably have heard the quote that said 90% of the job that children will do when they will be older actually does not exist, because they will be programming or coding jobs. Also for the entrepreneurial aspect, which gives the learning how to code actually gives the opportunity to students to think of a way that they can solve a problem by their own, and this is this sense of autonomy and entrepreneurship that can be developed. But general development of 21st century competencies, as the main competency being the computational thinking, and this on that third reason that we're going to focus on. So computational thinking represents a universally applicable attitude and skill set. Everyone, not just computer scientists, but everyone would be eager to learn and use. For example, a student will learn and use programming concept and process in order to solve a problem. And this is something that they might use in their in a daily basis. This requires creativity and the ability to represent multiple abstraction, to represent themselves, how our program can actually produce an outcome simply reading code lines. So it can develop that creativity by looking out for a unique answer to problem, but also the ability to represent that outcome by simply reading codes. Brennan and Resnick proposed 3 dimensions of computational thinking. First of all, the computational concepts. So, every concept that are used by programmers, which we can refer to words that we use in every language. So what they means, what their functions. For example, I'm taking verbs, articles. What is their functions in a sentence? On the other hand, if I take a concept or variables that are used in program language, what they mean, and what their functions for that program. Computational. The second dimension would be that computational practices. The process of solving problems, which is the main objectives of coding. You write code in order to address a problem, to start from point A and go to point B to address a problem. And the last one being the computational perspective, developing a better understanding of technology and the students' interaction with the digital world. This is the 3 dimension of computational thinking defined by Brennan and Resnick in 2012, and it can also refer to 3 different kind of knowledge that we teaching or developing amongst students in our curriculum. For example, in mathematics, we teach what a triangle is, and that which would be the computational concept of the triangle. What is triangle? Computational practice. So how to draw a triangle, a different kind of a triangle. How to draw them. That would be that computational practice, and computational perspective would be that a better understanding of the Pythagorean theory. A square plus b what is c square equals a square plus b square. I think this is a long time not hearing of that, but that computational perspective means that having a better understanding on how coding can affect our daily lives. And today's learning of programming in schools are mostly made by using a more visual representation of the language rather than learning in the traditional way. For example, the software Scratch, or for K-12 students, Scratch Junior, or the website code.org, etc., are tools that offers a more concrete way to understand code. So it is more accessible, and the step is not it reduce the gap between, you know, the starting point of students and the first step in learning code. Sorry, and like I said, robotic, for, you know, for example, Bbot, Ozobot, and Neo, the robot, etc. Is robotic is another good example of how we can visually represent the language of coding. And why? Yeah, it's another good question. Because it makes coding more accessible by facilitating the syntax and making codes meaning closer to written or spoken English meanings. So, you know, there's no confusion. Yeah. So reducing the cognitive load of students, allowing them to focus on the logic and structure. Sorry if you're not able to see that. So yeah, reducing cognitive load of students, allowing them to focus on the logic and structure rather than worrying about the mechanics of writing programs. So they can, you know, easily develop those second order skills like critical thinking, like problem solving, instead of putting energies to remember, oh, what does that how to I don't know, what does the semicolon means, or what, how to write a variable with no capital letters at the beginning of a variable or not. You know, instead of thinking of all those technical stuff, we're focusing on the logic and structure behind coding. Yeah, and what's the learning outcomes of coding? Because we haven't had the time to discuss very much of that, because this is something that's very new. That is new. This is something also that is not mandatory, as I should say, in well, at least in today's Quebec's curriculum. The learning outcomes are, you know, widespread. They are it vary a lot. There are multiple, but there are like other outcomes of a technical digital software or other ICT. You know, the outcomes is actually contextual. So the main, and most of the time put forward in researches, so the main outcome of coding is the development of problem solving skill and critical thinking. This is something that most of author, if not the unanimity of the author, are saying that, yeah, you know, coding actually developed problem solving skill amongst the students, just like mathematics doing. Because student has to analyze the problem, to determine what comments to use, yeah, you know, using as less comments as possible. Just when we're solving a mathematical problem, we need to use less step as possible, which, you know, refers to high order thinking skills. So you don't not only have to memorize something and, you know, vomit it on your exam sheet. No, you have to develop other skills that requires a deeper analysis, a deeper investment in that kind of in that activity. It was also noted that collaboration was identified as an outcome of coding. Of course, if the coding process is made, you know, is not individual. And this is something that authors also noted, is that putting or allowing students to work together to solve a code programming problem is actually a good idea, because they will, you know, exchange, they will talk about their programs, they will talk about the command they have used, and this is where the um, the cognitive uh, this is where when students will be able to share their own thinking on what is the best problem, what is the best way to solve a programming problem, is to interact with each other and look for other answers when they're stuck at a point in their programs. And yeah, to the ability to properly communicate with their peers, and also the ability to for their peers to understand their program, their coding, because like I said, there's not universal way to code. There's no universal language in coding. There's multiple way of code. Just like when writing an essay, there's the writing style of people that is that can alter the reading and the understanding of a message, either if it's from an essay or from a program. So not only when asking or giving other students for help with their code, but also when discussing around the activities and issues they've encountered during tasks. So this allows students to think of, oh, I can do that differently. I can, instead of using that comment, I should have used that other comment. Yeah. This also promotes coding in school. Also promote the active learning, so the process where students have control of over their own learnings. And active learning can be an outcome of coding. Learning at their own pace, own pace. It always depends on how you promote that kind of activity. Autonomy and self-directed learning can also be developed. And also creativity as an outcome of coding, because students are invited to find an innovative way or a new way, a novel way to solve a problem. So there's no unique answer or path to a program problem. And difficulties and misconception about coding. I'm going to go relatively fast for that part. Not because it's not important, but this is something that can that can seem to be obvious, and we discussed about. So it is first important to note, like I said, like we talked about, that there is three types of knowledge in coding. Well, first of all, there's syntactic knowledge, there's conceptual knowledge, and there's strategic knowledge, and it refers to those three dimensions identified by Benin and sorry, I do not remember the authors' names, but anyway, and difficulties can be linked with a misunderstanding of some element included in each of those type of knowledge. For example, if I not able to understand a variable that is written in English, that is using an English word, if I'm not able to difference to make a difference between the meaning of that variable with the actual meaning in the English language, there will be difficulties for conceptual knowledge. Syntactic knowledge, if I do not know how to use a semicolon in my program, it can cause some difficulties, because semicolon doesn't have the same function in a program as it can have in English or French language. Language are also something that can that can impede the learning process of program. Because, for example, I'm teaching coding in a French school, but programming is using English. In every program, English is used as the common language of those variables or those other programming words that we use. That can cause difficulties. For example, a student might mistakenly believe that the English meaning of a variable name affect its value. Because coding is a language, it comes with its own rules, meaning, and syntax. And even if it's hard to predict what difficulties students are going to encounter, some factors can contribute to reducing their impact. Those difficulties impact on that on the learning outcomes of coding. For example, the complexity of a task, the cognitive load also of a task, the natural language. Like I said, the meanings of variables, of words that we use in programming are not the same as the words we use in English. So the natural language might become a difficulty for students. Mathematics prior knowledge also, because coding is a mix of English language and mathematics mathematical thinking, or problem solving, and uses some variables and some concept that is directly taken from the mathematics field, and not understanding those prior knowledge, those mathematics prior knowledge, might become difficulty for students. Inadequate patterns and strategies used, environmental factors can be also a difficulty. Teachers' prior knowledge of programming can also be will of course be will of course have an impact on students' learning. And the best way to learn, for a teacher to learn how to code, is actually go on those websites. For example, I mentioned code.org, and do those exercises, or simply download Scratch or Scratch Junior. Find a way to actually be active in that learning, so you will have a better understanding of patterns and specific rules of programming, and gradually learning those rules, and you will be able then to will better be better to teach those concepts. Engage students in self-explanation and peer review of codes. Like I said, social interaction are something that can facilitate code language learning. Use metaphors to relate programming concepts to their prior knowledge. I'm going to give a quick example of me teaching some face-to-face teaching in front of a class. Was the main idea behind coding. So basically what I said is that I was in front of the class, and I asked students to raise their hand, and the objective was for me taking a piece of paper and give it to students. So because programming is one step at a time, students cannot simply raise their hand and say, Sam, take that sheet of paper and give them to, I don't know, Susie. So yeah, so they had to split, that action I usually will be making without even thinking of those specific and particular action. So I asked them what's going to be the command or the variable that is implied. So yeah, they basically said, oh, there is the Susie variable, the paper sheet variable. There is, hand variable, because I have to give comment or something like that. So they basically said, okay, make a step forward. So I make a step forward. Turn 90 degrees to your right. So I turn 90 degrees to my right. Raise your hand. So I raise my hand. No, not that much. So it was a social construction, even though we're not using real variable, or we're not using real syntactic or rules that are commonly used in programming language. Students were still able to think of how to solve that particular problem by splitting relatively well, an action that looked simple in multiple different pieces of actions. So that can obviously and it actually facilitates the learning of understanding programming, organizing their thinking by using mind mapping. So writing on the paper what you want to do and what are the steps you want to take in order to achieve that objective. Ask questions about what's the desired final outcome of students' program. This is something that we sometimes lose the sight of when we're writing a program, that we're so into those specific lines of code that we sometimes miss the final outcomes that desired, and also define your pedagogical intentions would be another thing to have in mind. To make sure that the coding experience as a learning outcome, teacher must, well, first of all, guide the experience, including defining the pedagogical intentions and questioning the problem-solving process of students. Because, like I said, this is not something that is technical. It's not something that we, mechanically doing. That student is going to do, and when the problem is solved and we go to another problem. This is something that we have to better understand, deeply, a deeper understanding of this process. Encourage students to reflect on the process, right, rather than simply try to have the right answer, because the process, the path that they're going to take in order to address a programming problem is, the most important thing in programming, in learning programming. And link the programming experience with authentic problems that are relevant to the learners. This is something that might be difficult to achieve, but if authentic means having a bee traveling to the flower, well, this is something that can be authentic. The point is that you have to, the students have to have a visual representation of the outcome of their codes, of the outcome of their programming, of their program. And well, finally, I ask you to go watch those three videos. Sorry, especially those two first videos, which is, well, first of all, a CBC journalistic story about a teacher that talks about his experience of teaching programming elementary school, kindergarten students that are learning coding, and this is something that is really interesting to hear. And the second video is a TEDx talk, and it's called "Why Teaching." Well, the video title is "How to Teach Programming to Kids," but the guy simply not talking about how, he's simply explaining why we have to teach code to kids. So there's a lot of information that can be retrieved from those two first videos. And finally, well, if you do have time, the last videos is about coding explained by kids. So he's a kid that followed a programming class, and is talking about his experience, and he's talking about why every kids in the world should learn how to code. So this what and this is, yeah, like as usual, the reflective logbook, the sixth entry of the second reflective logbook. The fifth entry of that reflective logbook is at the end of the last PowerPoint of the last class PowerPoint when we discussed about big data and cybersecurity and privacy on the internet. That's what the fifth entry is actually at the end of that PowerPoint presentation, and this is the sixth entry of the second reflective logbook. So I ask two questions here. First of first of all, should the government include coding in the official curriculum as an essential subject? Just like mathematics, English, history, etc., for kindergarten students, and explain to me why. And the second question that I want you to reflect on is is until this official implementation of coding in the curriculum. So if that ever happened, because actually it is not something that is mandatory for teacher to teach. Coding is not mandatory in our today's curriculum, but can record it's actually record on the internet, but record what I say right now is that it will one time happen. But will you, if that ever happen, will you integrate coding in your teaching lessons? So until it is mandatory, until until that teaching learning is mandatory to do for teachers, until that, will you integrate coding in your teaching lessons? You can answer yes or no. This is not the important part. What I want to know is why you will integrate or not coding or programming in your teaching. So these two questions are relatively simple to answer, and this is even more simpler if you go watch those videos. I really encourage you to go watch those videos before answering those two questions for the sixth entry of the second reflective logbook. So yeah, this is what wraps up the today's class, today's course. So if you do have question, you can always email me If that question is too complicated, you can ask. If you can call me as well. I will be available for answering those your questions. And this was something that was really hard to think of. I mean, how to introduce coding without losing every student's in all those technical aspects of coding. I really wish that we had the opportunity to explore, to experiment coding together. If we were face to face, it would certainly have been something that I would have introduced in that class. But if if you want to really have a better idea of what coding can look like and how accessible it can be for students, I really encourage you to go on code.org and take randomly select a coding exercise and try it try it on your own without having any prior knowledge, without having any knowledge of programming or a coding language. Simply go on that website or download Scratch Junior software and try it. Really try some exercises, and you will know that it actually is, well, I will speak for myself, but I think it's kind of fun. It's kind of a fun way to learn something that can be as abstract as a programming language and coding. So yeah, this is it. So if you have questions, don't hesitate to send me an email or personally call me, and I will try to address that question as quickly as possible. And yeah, and until then, take care of yourself. Have a wonderful, not so sunny day, and we'll see you next time. Bye.